One shot. Sound. So we'll go strictly with what you call the NCERT curriculum. If you have any additional questions, we can ask, but we'll try to finish it in 1 hour. Let's see how quickly we can do. So sound. What all we need to know? A form of energy. Okay. What is it caused by? It is caused by vibration. These are your keywords for your grade 9. It is caused by vibration. So every object which creates sound, or every object which is sonorous, objects which are sonorous, you know the meaning of the word sonorous? You've heard about it in grade 8. Sound. We say metals are sonorous. Metals are sonorous means metal like a bell. A bell makes sound. Everything that makes sound will actually undergo vibration. Only when you have vibrations, then only you'll create sound. And sound will always need a medium to travel. Okay, keywords I'm saying. Sound will always need a medium to travel. Before going further into it, we should also know that sound can also be represented by wave. So let us understand few things about wave mechanics very quickly and very shortly. Waves. Waves are again of two types. There are two classification of waves. One type of wave we will say as mechanical waves or matter waves, as they say, mechanical waves. And another would be electromagnetic waves. This is what is the sun's ray, electromagnetic waves. Mechanical waves are the waves which need a medium for propagation. That means in our chapter, our sound actually falls under mechanical waves. Electromagnetic waves are the waves which do not need any medium for propagation. So everything that you see in the EMS, electromagnetic spectrum of the sun, all these are electromagnetic waves. They can travel in vacuum also. Just generic knowledge. इसमें examples क्या क्या हो जाता है? गाड़ी, X, UV, in, my, range. मतलब gamma rays, X rays, UV, infrared, microwave and radio wave. Also between these two you have got your visible part of the sun's electromagnetic radiation, which is called light. All these are examples of electromagnetic waves. They do not need any medium for propagation. That's why when you are on moon or we are in space, you can talk to each other using radio waves. We can use microwaves and we can talk. However, mechanical waves will always need a medium. So sound is a mechanical wave. Itna clear ho gaya? Right, fine. Another way of differentiating waves will be transverse wave and longitudinal wave. Please understand, this is a complete different way of what you call categorizing wave. This is a different way. This is based on medium. This is based on medium. This is based on medium. अगर मीडियम चाहिए तो मैकेनिकल, मीडियम नहीं चाहिए तो इलेक्ट्रोमैग्नेटिक. ट्रांसवर्स एंड लॉन्गिट्यूडिनल. दिस इज बेस्ड ऑन व्हाट? दिस इज बेस्ड ऑन डायरेक्शन ऑफ वाइब्रेशन, है ना? जो बॉडी वाइब्रेट कर रहा है, डायरेक्शन ऑफ वाइब्रेशन वर्सेस डायरेक्शन ऑफ प्रोपगेशन ऑफ वेव. वेव कैसे जा रहा है और बॉडी कैसे वाइब्रेट कर रहा है, ये जानना जरूरी है. फॉर एग्जांपल, if the body is vibrating at 90 degree to the direction of propagation of the wave, body is vibrating like this and wave is going in this manner, then what do we call it? We call it transverse wave. ये transverse wave है. In transverse wave, our body will be vibrating. So let's say we have a body and the body is spring में है, यहाँ पे जा रहा है, यहाँ पे जा रहा है, transverse wave. So in that case, the wave is known as body vibrates up and down, that is at 90 degree to the direction of propagation of the wave. Wave इस side जा रहा है, body is vibrating. The best example is go to the gym, take the gym rope, tie a small ribbon on that and start doing the waves. How do you see? How do you see? You see as if waves are going, but if you concentrate on that ribbon, you see the ribbon going up and down, up and down. And in waves, always remember, matter does not travel. For wave, one important thing was it's only the disturbance that travels. A lot of videos on waves are there under IGCSE or CBSE. You can go through anyone. It's only the disturbance that travels. Particles of matter remain at their same place. If you ever have a doubt, ask yourself how a football stadium wave is created. No person changes, 1 minute, no person changes his position from that stadium. He just gets up and gets down, gets up and gets down. but the person on the other side of the stadium watches as if a wave is propagating. Yes, Rishabh darling, boliye.
So it's like if we tap on it taps forward, we hear the sound of like tapping the object, or we hear the sound of the movement as well.
Which one? What did you say? Say again. Give me an example and then tell.
So like if I push the pen forward, then will I only get sound of this or even movement?
Not movement. It is the column associated with that particular pen has started vibrating. The pen, when you strike the pen, you actually create a vibration. The pen creates a vibration in the air column. Ultimately, what is coming to you is the vibration of the air column. If that vibration is very small, you don't hear it also. Are you getting it? So for any, that's why I said a wave is a disturbance. Wave is a tool used to understand electricity, used to understand sound, used to understand light also. How does sound propagate? To understand that, we should know wave mechanics. Wave एक tool है, इसको हम लाइट के चैप्टर में भी यूज कर सकते हैं, इसे हम ऑल्टरनेटिंग करंट में भी यूज करेंगे, इसे हम आगे जाके एनी सिंपल हार्मोनिक मोशन में भी यूज कर सकते हैं. Wave is, as I said, it's like love between of various relations. You have different type of love. So wave is like that. Sound, to propagation of sound for understanding, we use the tool of wave mechanics. So in wave mechanics, few things that you should know, whether it's there in your book or not. Waves can be classified on the base of medium. Waves can be classified on the base of direction of vibration versus how the wave is propagating. If the particles are vibrating up and down and the wave is going straight, then in that case we call it as a transverse vibration, transverse wave. Like, so for example, if you see water waves, ripples, पानी में रह के आप ऐसे पत्थर फेंक दीजिए and you keep a small leaf, the leaf will just go up and go down, but the ripples keep on spreading. That's transverse wave. Another wave is longitudinal, where if this is your direction of wave propagation, your particle will be vibrating to and fro along the direction. देखिए दोनों में एक फर्क है, यहाँ to and fro at 90 degree, यहाँ to and fro on this side. So the best example is using a slinky. As a slinky, this is a spring is known as a slinky. So if you take the slinky and you just pull and release the slinky in a horizontal manner, then you will see the slinky forming these sort of patterns. This is what we call as a compression pattern. This will be a rarefaction, compression, rarefaction. Again the same spring, tie a red ribbon to this spring, एक red ribbon यहाँ बांध दो, and now this time you do the spring ऐसे ऐसे घुमाना शुरू करो. So how do you see your spring going up and down? You will see that your spring will now go up like this, go down like this. So the slinky can be used to create both transverse as well as longitudinal wave. ये आपके नॉलेज के लिए, क्योंकि इसको आप नेक्स्ट पढ़ोगे जाके 11th क्लास में, 10th में ये है नहीं. That time it should not appear absolutely new to you. इतना समझ में आया. Sound हमारे लिए mechanical wave है. And what is the medium through which sound is traveling? Air. Usually when you are hearing me, unless and until there is a train coming and you're putting your ears on the track of the train, then the medium is the track, which is the solid medium. ठीक है ना? So sound needs a medium to travel, and that's why sound is a mechanical wave. And if we go, so if we classify on the basis of medium, sound हो गया mechanical wave. If we classify on the base of direction, then sound is a longitudinal wave. ये दो आपको, these two you should know. Sound is a mechanical wave and sound is a longitudinal wave. यहाँ पे कोई doubt है तो पूछो. Sir, why mechanical wave? Because sound needs medium. Sir, why longitudinal wave? Because in sound the particles vibrate along the same direction of propagation of the wave. So sound is going to create, sound waves will have compression and rarefaction in them. ठीक है? And then when you actually show the wave in terms of wave graphics, then every zone can be now represented as a crest and a trough. Crest is if your compressions are representing crest, then your rarefactions are representing trough. ठीक है? 9th grade में हमें जो चीज चाहिए समझने के लिए इसमें, that is, we should understand some parameters related to the wave. That is number 1, what do you understand by amplitude? What do you understand by frequency? And what do you understand by time period? इसके ऊपर आपको एक न्यूमेरिकल डाल सकता है. And what do you understand by speed of the wave. सीधी सीधी बात. So let me draw a wave pattern. Okay, this is my wave pattern. Now, if I'm mapping this in terms of time axis, okay, if I'm mapping this in terms of time axis, then one crest, this is my crest and this is my trough. इसको हम क्या बोलते हैं? Trough. Okay, and this is crest.
So this is one wave.
One crest and one trough will make what is known as one cycle. One cycle. In your bhasha, it is known as one oscillation, or it is one vibration. Have you understood? If you see it in terms of the pendulum, and this is the central position, that is, this is the central position, then going from central to the extreme right, this is half wave, half cycle, again coming back is another half cycle. तो जाने का अगर आप crest से दिखा रहे हो, the return is on trough. Are we fine? Clear? So this is known as one cycle. One cycle is one vibration. One vibration means one vibration नहीं बोलते, one oscillation. One oscillation is one to and one fro. जहां से गए थे वहीं लौट के आओ. Have you understood? So you will have two crossovers. आप दो crossover मार के जाओगे, फिर आके यहीं पे पहुंच रहे हो. Right? So is crest and trough okay? Now we should understand what is amplitude. This is known as my mean position or central position. Maximum displacement that you take, okay, the maximum displacement that you will be taking, maximum displacement, this is what you will study in 11th grade. If a pendulum is undergoing so much of angular deflection that it is actually creating a curvaceous path, then this is oscillatory motion, not simple harmonic. In simple harmonic, your deflection should be very small so that you can compare them as linear displacement, straight line. बहुत फर्क है. चैप्टर एनसीईआरटी बहुत छोटा कर दिया है. सबसे पहले आता है पीरियोडिक मोशन. एनी मोशन which keeps on repeating itself is called periodic motion. फैन घूम रहा है, this place will again come after some time, again after some time, periodic motion. पर ये पीरियोडिक में क्या है? रोटेशनल मोशन. बच्चा झूला में झूल रहा है, पीरियोडिक. I told you ना, the mother can actually talk and feed the child because she knows अब बच्चा आ गया, खाना ले लो, अब खाना ले लो. पीरियोडिक है. बिना बच्चे को देखे आप खाना खिला सकते हो. But that motion is not simple harmonic. That is oscillatory. गिटार का स्ट्रिंग वाइब्रेट हो रहा है, वाइब्रेटरी. हैक्सॉ ब्लेड क्या जा रहा है, that is simple harmonic. In simple harmonic, later you will understand, acceleration should be proportional to negative of displacement. Pass. If you can create this scenario, then that motion is known as simple harmonic. If we can create this particular scenario. If I do this, then this one will go away. Where is this button gone? It should come out from here only. 1 minute. 1 minute. 1 minute. Yeah. This will learn in grade 11. If you can show that acceleration is negative of displacement, then only it is a simple harmonic motion. ये भी देख सकते हैं कैसे होता है, कोई बड़ा इंजीनियरिंग नहीं है इसमें. ठीक है. So in terms of a pendulum, if you want to understand what is a cycle, 1 to and 1 fro. अगर 2 को आपने क्रेस्ट से दिखाया तो फ्रो ऐसे टॉप से जाता है. इस समझ में आया? Now let's understand first हमारी चीजें देख लेते हैं. What is amplitude? The maximum displacement from the central mean position to either of the side. Means in the case of a wave, this will be my amplitude. That is positive amplitude, this is negative. अगर आपने इसको positive माना तो ये negative है. But from the mean position. Remember, always from the mean position. That is known as amplitude. Okay. Time taken to complete. अगर ये हमारा t time पे complete हुआ, then t is known as the time period, time taken to complete one oscillation is called time period. एक साइकिल होने में कितना टाइम लेता है, हमेशा पूछो, एक साइकिल होने में कितना टाइम लेता है, that is called time period. What is the time period of the earth for its periodic motion? 365 and 1/4 day. अभी तो तुम 2 दिन पहले रात रात भर नाचे थे ना बेवकूफ की तरह. Why did you dance? Because अर्थ का टाइम पीरियड हुआ था. अर्थ just made its time period. Yes or no? Time taken to complete one cycle. रोटेशनल मोशन का टाइम पीरियड क्या है? 24 hours. Very good. Right. So like we are studying physics today, we'll study physics again on Tuesday, next Tuesday. So our time period for physics cycle is 7 days. 1 week, which is also known as 7 days. ठीक है? क्या एम्पलीट्यूड को टिक मार्क कर सकता हूं? एम्पलीट्यूड इज द मैक्सिमम डिस्प्लेसमेंट फ्रॉम द मीन पोजीशन टू आइदर ऑफ द साइड्स. एम्पलीट्यूड इज आल्सो अ मेजर ऑफ लाउडनेस. कोई भी साउंड अगर लाउड है तो उसका एम्पलीट्यूड लाउड है. कैन आई टिक टाइम पीरियड बच्चा? टेल मी, आर यू फाइन इन टाइम पीरियड? ओके, कौन सा टाइम पीरियड? ये बॉडी टाइम. इसके लिए पहले एक साइकिल समझो. एक साइकिल मतलब जहां से आप छोड़ रहे हो मैक्सिमम. हम यहां से भी छोड़ सकते हैं पर उससे समझने में मुश्किल होता है, तो इसको आप खींच लीजिए. एक मैक्सिमम यहां से छोड़ दीजिए, जहां तक गया वो है 2, वहां से फिर वापस आएगा वो है फ्रो. एक 2 और एक फ्रो से बनता है एक साइकिल. एक साइकिल को कंप्लीट करने के लिए जितना वक्त लेते हैं वो है टाइम पीरियड. तो हमारा जो पेंडुलम है, दादाजी के घर में हम लोग कहते हैं ना, उसे हम क्या नाम देते हैं? सेकेंड्स पेंडुलम. व्हाई डू यू कॉल इट अ सेकेंड्स पेंडुलम? 11 में पढ़ाते हैं. बिकॉज उसका टाइम पीरियड 1 सेकेंड है, तभी तो वो घड़ी है. आई कैन हैव अ पेंडुलम ऑफ एनी मेजरमेंट, but in a watch shop the pendulum that you see, that is a seconds pendulum. Why is it a seconds pendulum? Because it exactly takes 1 second to complete a cycle. इसलिए तो वो घड़ी है. समझ में आया? अब आते हैं फ्रीक्वेंसी में. फ्रीक्वेंसी और टाइम पीरियड आर जस्ट रेसिप्रोकल ऑफ ईच अदर. लेकिन फ्रीक्वेंसी को समझते हैं. फ्रीक्वेंसी का यूनिट होता है, फ्रीक्वेंसीज यूनिट इज हर्ट्ज. ऑल्सो many people write it as cycles per second, और many people also write it as second minus 1. कोई भी एक, ये ज्यादा चलता है. दिस इज द SI यूनिट. टाइम पीरियड का यूनिट होता है सेकेंड. फ्रीक्वेंसी क्या है? फ्रीक्वेंसी कहता है 1 सेकेंड में. आइस क्यों रेड है? सोए नहीं क्या? ड्रैकुला बन गया हो क्या? सुबह से ही रेड है. 1 सेकेंड में कितना साइकिल करते हो? वेरी इंटरेस्टिंग. लेट्स से माय टाइम पीरियड इज 1 सेकेंड. Then what is my frequency? 1. मैं अभी देखो, इसको हिंदी में समझो. मैं एक साइकिल करने के लिए 1 सेकेंड टाइम लेता हूं, तो मेरा टाइम पीरियड हुआ 1 सेकेंड. मैं 1 सेकेंड में एक साइकिल ही कंप्लीट कर पाता हूं, तो साइकिल्स पर सेकेंड अगर कोई पूछे तो मेरा कितना हुआ? 1 CPS और 1 हर्ट्ज और 1 सेकेंड इनवर्स. अब लेकिन सवाल घुमा के पूछ रहा हूं. To complete one cycle, I take 2 seconds. What is my time period? 2 seconds. Therefore, in 1 second, how much I have done? Half the cycle only. So, my frequency becomes 0.5. देखो अभी हमने क्या कहा था? हमारा टाइम पीरियड है 2 seconds. तो हमारा फ्रीक्वेंसी कितना निकला था? हाफ ना. फ्रीक्वेंसी इज ऑलवेज 1 by टाइम पीरियड. 1/2, which is nothing but half, which is 0.5. अब दूसरा सवाल. I complete one cycle in half second. What is my time period? Half second. What is my frequency? 2. Because in half second I complete one cycle, that means in 1 full second I will be completing 2 cycles. समझ में आया? आपके घर में जब बिजली आ रहा है भाई साहब, वो कितने का है? 50 hertz. How will you interpret this? The alternating current that is getting supplied in our house is having a frequency of 50 hertz. What do we mean by that? It says that in 1 second, the signal is oscillating how many times? 50 times. That means it is changing over how many times? 100 times. एक साइकिल में 2 चेंज ओवर होता है, एक बार अप एक बार डाउन. Have you understood? So that's why you don't see the bulb glowing and blinking and blinking off. Otherwise, when you connect in AC, your bulb should once glow and one should switch off also, because the signal is oscillating. But it is oscillating at what speed? 50 cycles per second. And God has made you super fool. If I show you anything more than 1/16, then persistence of vision grade 8 tells me that the things appear continuous to me, time lapse. 1/16 के ऊपर आप बेवकूफ बन गए हैं. Anything which has a speed of, and if you slow down the speed, then you'll see one rolling, right? That's what we do in Diwali lights. All the lights don't glow. Light 1 glows, then light 2 glows. That time 1 and 2 are off, then 3 glows, 4 glows. At a time only one bulb is glowing. Now I start increasing the speed of my controller. How much? More than 1/16. And I make you sit at Aurum Tower रात को. Then what do you see? कोई आदमी ट्रर ऐसे जा रहा है. ऐसा थोड़ी जाता है. When you go to cinema halls, you see the dot matrix displays. Now showing Batman. Those are all dot matrix display. There are a lot of LEDs are there. But it appears to as if now showing is moving. How is it moving? They have just made it in that manner. It's more than 1/16. So alternating current. And in US, this signal is how much? 60 hertz. Means for them it is 60 times. So if you watch Tata Sky, then the signal that is coming to you is at something at 3200 megahertz. कितना fast आ रहा है वो signal. More is the frequency, more is the energy. A more frequency sound can travel much far off distance, which I've told you many times. A baby wailing at night can be heard far, far away. But a loud music system played in your house, you will only hear in your house maximum 2-3, उसके बाद die down हो जाएगा. उसमें उतना intensity नहीं रहता है. It all depends upon frequency, and frequency depends upon source. If source does not change, frequency never changes. So more is the frequency of a sound. That's why we say gamma rays, X rays. These are short wavelength, but very high frequency. They can penetrate concrete and go away. But if you go to radio waves, their wavelengths are very big. Still big enough for us to travel. हमारे लिए enough है travel करके आ जाना. But their wavelengths are bigger and their frequencies are smaller. ठीक है? तो क्या मैं frequency को टिक कर सकता हूँ? भाई साहब आधा घंटा हो गया, जल्दी जाना है. ठीक है? Clear? Okay. Next comes speed. Speed बोले तो क्या? Speed is how the wave is propagating. How the wave is propagating. मतलब I can draw this on an axis of time, or I can also draw this on an axis of length. If I draw this on an axis of length, say x, then how much has the wave propagated? Wave भी तो जा रहा है ना आगे. वो है wave की speed. अच्छा, उसको जानने से पहले we'll need to know something called wavelength. So what is what wavelength? One wavelength is the distance traveled by the wave over one cycle. एक साइकिल में जो पार्टिकल यहां पे था वो कहां चला गया? सर यहां तक चला गया. So this will be called as one wavelength. One wavelength is one crest plus one trough. Two crests will also give you one wavelength. Two troughs or 2 points on the same phase. Two adjacent points on the same phase is also one wavelength. इतना जानने की जरूरत नहीं है. आइए, your definition which you need to know is so time period. These two equations you should know for your grade 9. T is equal to 1 by f, and the speed of the wave is always given by frequency multiplied by the wavelength, which is lambda. Wavelength. Units check कर लीजिए. Wavelength होता है मीटर, frequency होता है 1/second. That is nothing but velocity, which is meter per second. We are correct. इसके ऊपर कुछ सवाल दे देगा आपको और उसमें आपको बेवकूफ बनाएगा. They will give the wavelength in some centimeters, nanometers, micrometers. So please ensure that whenever you are getting the wavelength, आपको wavelength मीटर में ही लेना है. And I hope you know. ऐसे लिखे तो what does this mean? Hey, milliseconds. Milliseconds. Milliseconds means 10 to the power minus 3 seconds. ऐसे लिखे तो क्या है? Microseconds. 10 to the power minus 6 seconds. ठीक है ना? ये माइक्रो है.
Oh, the U type.
हाँ, mu. This is called as, pronunciation is mu. M-U, mu. This is micro, this is milli. Milli is 10 to the power minus 3. ये करेगा आपके साथ. No, you are not a grade 4 बच्चा that people will give you time frequency is this much, time period. ऐसे भी नहीं. और नहीं तो कुछ और देगा. कैसे देगा? A simple pendulum completes 30 oscillations in 15 seconds. 30 oscillations in 15 seconds. That means for 30 oscillations, you need 15 seconds. For one oscillation, you need half second. So your time period is half. Your frequency is 2. वहां से आपको frequency निकलेगा. उसके बाद वो दे देगा that the wavelength observed is so and so. And then you multiply the wavelength with the frequency to get the speed of it. Yes.
Like instead of frequency equals 1 upon time, can we also write it as like number of waves by time?
Number of waves means if you do number of waves is not the correct number of cycles.
Number of cycles
Cycle.
by time.
That's why it's CPS na unit.
Yes, sir.
But the time should be measured in seconds. Then you will get the frequency in hertz.
So then what is the use of two formulas? Like,
Two formulas means
like frequency is also 1 by time, frequency can also use as like number of cycles.
आप इसके बाद frequency ऐसे भी पढ़ेंगे. ओमेगा इज इक्वल टू 2 पाई एफ भी पढ़ेंगे 11 में. ऐसे भी frequency आएगा. तब क्या करेंगे आप? थर्ड फॉर्मूला आएगा. Then frequency will also come as some other formula. आधा 1000 बार आ सकता है. This is when rotational motion comes up. ठीक है? Just for your knowledge, if you want, absorb करना है करो, नहीं करना है मत करो. मतलब कोई there's no what do you call जल्दबाजी on that, but it's up to you. See, this is your pendulum, right? This is my pendulum central position. Agreed? And then the pendulum swings and goes where? Here. ठीक है? Here, like this, and like this, right? You should actually see what brings the pendulum back. So pendulum का अगर आप, if you try to do the force analysis of the pendulum, then there is a weight of the pendulum which is acting downwards, mg. The pendulum has been deflected by how much? Theta. And the रस्सी is keeping the pendulum straight. So there is a tension. टेंशन निकालने के लिए जहां टेंशन निकाल रहे हैं वहां से बैठ के छतरी खोल दीजिए. हमें यहाँ पे टेंशन चाहिए ना, यहाँ बैठ के open the umbrella. So tension is always upwards. This is tension. Understood? Now what we do is that we just break it into its vector terms. So let's say if you extend this like this, if this is theta, then as per geometry corresponding angle, this should also be theta. And then you break mg is a force, so we break mg into its components. One component this side and one component this side. What is this component? Mg cos theta. So this will cancel out tension. So you have one unbalanced force which is mg sin theta. Mg sin theta is bringing you this side. And so the force acting on this particular bob is how much? Negative of mg sin theta, because displacement इस side था, force इस side है, negative होता है. और न्यूटन क्या कहता है? So it should be the mass into the acceleration. So mass into acceleration should be equal to negative of mg sin theta. Mass cancels mass. So A is equal to negative g sin theta. Right? What we have to prove for simple harmonic? A should be directly proportional to negative of displacement. This is what you should get. This is what is in grade 11. So A is equal to negative g sin theta. But in simple harmonic, theta is very small. When theta is very small, very small, at that time, sin theta is approximately equal to theta. So A becomes minus g theta. ये एक और हो गया.
In simple harmonic.
No, simple harmonic you have to arrive this. And in simple harmonic, आप इतना नहीं दे सकते. It should not become curve. It should become सीधा. Right? Then again, theta we say, theta in radian measurement we say, theta, this is the length of this pendulum L, and this much portion is how much? X. So it becomes X by L. चलो ये आपको बोर हो जाएगा. So theta is equal to X upon L. So here we say A is equal to minus G X upon L. And now what do we get? Now we get A is equal to minus G. So it becomes minus G by L and X. This minus g by L is a constant. So acceleration is, g by L is a constant. So acceleration is a proportional to negative of displacement. So it is simple harmonic. ये 11 में पढ़ेंगे. अगर वहां पढ़ना है तो आपका at least ये सब concept clear होना चाहिए. That Otherwise, why is the pendulum coming back? कोई तो ला रहा है ना वापस. This force is bringing it back. So when your teacher draws a mg sin theta in grade 11, they will not have that much time to teach you so much of basic. नहीं है. There, that time you should understand, okay, he has resolved it. And when they have resolved it, then we resolve it into what? This is our y-axis, this is our x-axis. So in x, we have a...
So the x-axis you just made, will that be negative?
Which one?
This extension you made on the right.
No.
The x.
X-axis and this is y-axis.
Yeah, so won't that be negative mg sin theta?
Which one? This one?
Or the other?
That side we will never have mg sin theta. The force is this way. It gets split into these two components. Na? Why will I get a force on that side?
Okay.
Now somebody may ask you, see, in that also we can do some more interesting problem. Say suppose we have, अभी mechanics के problem ऐसे आएंगे, यहाँ पे एक bar दे देगा, and they will say a rope has been tied on this pendulum. Calculate the tension faced by this particular rope or the thread. The tension will be equal to mg sin theta because that tension is holding the unbalanced force. Still more complicated if you do. It is still able, यहाँ पे spring डाल दो. It is able to pull the spring and come to some distance. Means there is a net force. The net force is excess of mg sin theta over the spring force. Physics कितना interesting किया जा सकता. Are you understanding? These problems you will integrate. Mg sin theta brings the pendulum back, but I am holding the pendulum back with a thread. So the thread is facing some tension. What is the tension? Mg sin theta, right? Now instead of the thread, I change it by a spring. Based on the stiffness of the spring, the bob will come to some place, may not fully.
Yeah.
At that time, the bob is experiencing a net force.
Yeah.
What is the net force? It is minus the spring force. The spring force which is trying to pull it backside. Spring force क्या होता है? Minus kx. So you have to equate that, and with that, your bob is coming. So they will not ask you what is the force. They'll ask what is the acceleration of this bob. So acceleration means a net. F equal to ma. What is your F? F net. Mass of the bob remains same. Then you get your a net. If these things are clear, then only maximum children complain in 11 because उनका ये सब clear नहीं रहता है. इसलिए उनको लगता है it's very tough. What they will do? mg sin theta के साथ force, and I'll divide it by the mass of the bob. I'll get acceleration. Net force. Always remember net force. So ये वाला clear हुआ. This is one portion of your exam. और अभी क्या है? बाकी तो सब theory है. Echo है, उसके बाद theory. So let's do some theory part. Echo भी समझ लेते हैं फटाक से. Echo. What is echo? Echo is when you are able to create a sound in a region where there is a barrier. That barrier has a distance from you, and there has to be a typical temperature setting. You should not change the temperature. That you don't study in grade 9. Sound. The speed of sound depends upon medium. Like sound travels fastest in solids.
Then heat also.
No, so sound travels fastest in solid, followed by liquids, followed by air. So we are now talking with we are hearing each other with the slowest speed of sound, which is around how much? Say roughly 344. Okay, let's take 344 meters per second. So let's keep our person. ये हमारा यथार्थ है और यहाँ पे एक हिल बना दो. ठीक है, एक हिल बना दिया. तो एको क्या होता है? एक बार आपने आवाज किया और कुछ देर के बाद आपको वो आवाज फिर से सुनाई दे रहा है. So you should have an obstruction where the sound will go and hit. But there are some clauses also. This obstruction should be at a particular distance, number one. Number two, there is also that the temperature should not change. So in terms of temperature, just as a dipstick, if you want to know, temperature बढ़ने से sound का speed बढ़ता है. Kinetic energy increases. Okay, sound का speed बढ़ता है अगर temperature बढ़े. So in order to hear two distinct sounds, the first one is the primary sound created by you and the second one is the secondary sound. There has to be a time interval of 0.1 second. नहीं तो इंसान के कान दो sounds को distinguish नहीं कर पाता है. Because we are also limited. Like our eyes 116, this is 0.1 second.
Like exactly.
It should be minimum 0.1 second difference should be there between the two sounds. Okay. Then only we will be able to hear two distinct sounds. So we use the simple formula. Distance is equal to स्पीड इंटू टाइम, है ना। स्पीड कितना है साउंड का 344, टाइम इंटरवल कितना है 0.1, तो कितना डिस्टेंस उस वेव ने ट्रेवल किया 34.4 ट्रेवल किया। कौन सा वेव? आपके जुबान से जो वेव गया और फिर जो वापस आया, इसके बीच में सपोज यू क्रिएटेड दिस नॉइज एट द 15 सेकेंड, दिस शुड मिनिमम कम बैक टू यू एट 15.1 सेकेंड में। उससे पहले अगर आ गया ना तो आप एको नहीं सुन पाएंगे मिनिमम। So in this time, how much distance did the wave travel? 34.4. 34.4. This is the time taken for two travels. ऐसे भी हम गए, ऐसे भी आए. So in one distance, if you see only this much distance, if you want to find out, so this will be 34.4 divided by 2, which is 17.2 meters. मतलब echo सुनने के लिए, what are the criteria? Number one, you should have a sound creating source like me. You should have a barrier, right? And you have no control on this 0.1. Ensure कि 0.1 minimum हो. अब 0.1 minimum कैसे करें? उसके लिए ensure that the barrier is at least 17.2 meters away from you. Have you understood? 0.1 से ज्यादा होगा तो हम बहुत अच्छे echo सुनेंगे. 0.1 से कम हुआ तो हम नहीं सुनेंगे. So the barrier should be 17.2 meters least. So if I am alone and if ये खंबे के साथ बात करेंगे echo नहीं आएगा. 17.2. Understood? Echo. Echo के साथ कुछ बच्चे confuse कर देते हैं. What is reverberation? Reverberation means that due to multiple reflection, sound दब नहीं रहा है. The sound is still persisting. Like I speak hello, it has gone. The sound is hello इतना बार reflect हो रहा है that the hello is still heard. Till the sound does not die its normal death. So if you are in a music room or something, or you are in a theater or in a movie hall, और जहाँ excessive reverberation हो रहा है, आपको दो बातों में तो म्यूजिक में डिफरेंस ही नहीं आएगा, because the previous music is not yet dying. Are you understanding? Echo is like what you see in persistence of vision. This is persistence of sound. So to kill reverberation, what do we do? In theaters, we make them curved. Curved means the sound will go towards the corners. And in corners again, for more better thing, what they do, they put a soundboard. Soundboard's job is, soundboard or megaphone, their job is after the reflection, this you'll learn in grade 10, when rays are coming through the focus, they travel straight. So in the case of a trumpet, if you see a trumpet or if you see a saxophone and all these things, उसमें ऐसा रहता है, it's made in such a shape that multiple reflections will make the sound travel in one direction. So please understand what is echo. Echo is the phenomenon due to which a sound is heard more than once. If there are more reflection, more barriers here, you can hear second echo, third echo भी होता है. You are just learning a very basic thing of what is an echo. Echo means एक sound को दो बार सुनना, दो से ज्यादा भी सुन सकते हैं. What is the criteria for echo? Your object should be minimum at a 17.2 distance. And the temperature should not change at that place. If temperature changes, again the whole calculation changes, right? Reverberation is multiple reflections of the sound due to which the sound still persists and the sound does not die. To kill reverberations in theaters, we will have soundboards which absorb sound and then produce the sound only in one direction. Number one. Fabrics. The seats are made up of all cushionable. Like if this room, I make it absolutely empty, when people come to visit a flat or they want to see a flat which they want to take on, और कहाँ कहाँ घर रहेगा, सोफा यहाँ रख दो. But when you start putting things, everything acts like an absorber. So reverberations are killed by making it curved so that they go to the corners, or by putting some soundboards even at the corners so that the sound travels in one direction. Application of reflection of sound is seen in stethoscopes. And certain shapes can be given in which the reflection of sound can be more better used, where cylindrical shape like in trumpets and all, where the sound, or in megaphones where the sound travels in one direction. So ये तो हो गया echo, reverberation and this. Okay. There are two more aspects you should know. How do you distinguish between two different sources of sound? By its frequency, which is also its pitch. And there is another thing called quality of sound. That is timbre. Quality of sound. Quality of sound, it will tell you like which is of a better quality. Like we said, noise and melody. Melody हम सुन सकते हैं, but somebody putting a drill machine, you will not hear. That differentiation is known as timbre. फ्रीक्वेंसी, ओके, फ्रीक्वेंसी के साथ आ गया ऑडिबिलिटी रेंज, ये भी तो है हमारे सिलेबस में. व्हाट इज द ह्यूमन ऑडिबिलिटी रेंज? 20 to 20,000 hertz. Okay, 20,000 hertz. So anything above 20,000 hertz is ultrasonic. Sonic means सुनना. 20 hertz से नीचे मतलब infrasonic. Rhinoceros actually communicate in. हाँ.
How did they find out that 20 kilohertz is the maximum amount of sound we can get?
You can generate a wave.
But then, like, was there a person who was using that?
You can hear it. If you have a variable ultrasound generator, you can start making it. After that, you'll hear that noise. Suppose there's that, as I told you, some mosquito. Mosquito repellents are available. So mosquito repellents are there, which are actually plugged onto your switchboards of your house. They are making noise, but those noise are ultrasound. मैं नहीं सुन पा रहा हूँ. Rodents can hear it.
20 kilohertz.
20 kilohertz. No. Audibility. Frequency has, it's not loud. It's not loud. It's frequency. We cannot hear anything more than 20. Like rhino. Rhinos communicate in infrasonic sound. Sonic means जो आप सुन सकते हो. Aeroplanes will travel which more than the speed of sound are known as supersonic. Ultrasonic is 20,000 के ऊपर. Speed of sound means sonic. Subsonic, sonic, supersonic. ये तीन अलग चीज हुआ. Subsonic means less than the speed of sound. Supersonic means more than the speed of sound. Right? At that time we start telling it Mach numbers we give. Mach 1, 1 times the speed of sound. Mach 2, Mach 3 ऐसे बोलते हैं ना. Supersonic. Like BrahMos is a supersonic missile. It travels more than the speed of sound. Then comes on to what? Ultrasonic, infrasonic. That is based on the human audibility range. Acha, now a question comes, can you hear supersonic sounds? Yes, we can hear supersonic sound. A supersonic jet, fighter aircraft जाता है तो हम कान बंद कर लेंगे ना. Anyone who has gone to Pune airport, if you stand in Pune airport and if you're lucky to see Sukhois taking over, then getting out in your hairs will stand up when you see the jet blast of Sukhois. Sukhoi is the base. And Pune airport, every 10-15 minutes, 2-3 Sukhois will take off. So it's a jet blast. That is what we call as a jet bloom. ठीक है? So supersonic. Applications of ultrasonic. ये सब question आएंगे. क्या हो गया? Number 1, cleaning is also one thing. Cleaning means where in spiral ducts and other places where you can't reach, the ultrasonic waves can actually reach and clean the duct. This is one. Second is ultrasound can also be used to probe organs. Okay, so you create, there are two things out here. One is electrocardiography, which is known as your ECG, jahan aap you send a lot of ultrasonic waves towards the heart and there are multiple reflections, and from that the imaging of the heart is done in the form of graphics. But ultrasonography is creating the impression completely, image completely. That's an ultrasound. Anyone has undergone an ultrasound? अच्छा, अभी experience ही नहीं हुआ है. There will be a probe, they will put it on your tummy. Lot of jelly will be put on your tummy and then the probe will be pressed hard. Once it is pressed hard, then your organ's image comes up. That is called ultrasound. Okay? But in our engineering also, like this concrete wall, whether the concrete wall has cured properly or not, you can also check through ultrasound. These are called NDT, non-destructive test. To check this roof, you need not break the roof. If you break it, then it is called a DT. Destructive testing, but we use what is called ultrasonic testing. That's NDT, non-destructive radiography, as we say. So if you have a crack, like say suppose this is a piece of concrete, so we will have our transmitters and we will have our ultrasound receptors. Okay, so transmitters will transmit. So ultrasound है, आराम से चला जाएगा. जहां क्रैक आ जाएगा ना, वहां अल्ट्रासाउंड जाके वापस आ जाएगा. These two transmitters will not pick up those two signals, meaning shows that there is a gap. Now question arises, इतना खर्चा क्यों सर, sound wave क्यों नहीं कर सकते? Sound waves will show diffraction. Diffraction is a process. Sound wave क्या होगा पता है? Sound wave ऐसा आके corner में bend मार जाएगा, जाके इसको pick up कर लेगा. So with sound you cannot check the crack.
Is there any like uses of infrasonic?
Infrasonic. Rhino? That is ultrasound. That is ultrasound. Rhino proposes another rhino through infrasonic. Their love language is infrasonic.
Communication.
We don't use infrasonic. Infrared we use for remote controls and all.
Yes.
Ultrasound इसमें भी use करते हैं ना, like ultrasound shocks can be used for like suddenly if you have a nerve pull, Suppose you are playing and a nerve has got pulled. So one of the ways to relax the nerve, either by massage, but immediately if you want to get cured, they have these ultrasound shock bars also. It immediately cures you. So you'll get up again on your feet quickly. So there's, have you seen those ultrasound shock? Ultrasound treatment is given in physiotherapy. People who travel, have you heard about a disease called sciatic compressions? Nerves will compress. There'll be immense pain on this side. It's a nerve pain. Nerve pains are very bad. Like bone pains, you can know. Nerve pains means andar hi tumhe kheench raha hai. All these will come to you not now, say now after 30, 35 years, suddenly you'll have a nerve pain. Nerve pain means you're unable to stand on your feet. It is paining you. Like for my mother, it happens. And then you can't stretch. You can't stretch. Cramp हो गया है और बहुत गलत, बहुत दर्द होगा. Immense pain. So at that time, ultrasonic treatments are also given. और कुछ है चैप्टर में जो छूटा है? Loudness will tell you intensity. Okay, the amplitude. Like for example, if you have a sound wave, the amplitude tells you about the intensity of sound. If you have a light wave, the amplitude will tell you how bright the light will be. जैसे आप गाना सुनते हो ना, all this auto rickshaw वाला जो बजाता है, dig dak, that's all loudness. So the speakers have bigger membranes. They are able to go up and down ज़्यादा जाते हैं. But that's not good sound. वो यहीं पे सुनाई देगा, दूर तक नहीं सुनाई देगा. दूर तक सुनने के लिए बच्चा रो दिया ना, that you can. If a bell has been, you take a ice cream wala's bell and ting 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 karo, that you can hear from. That's why church and all these places have this bell. चर्च का बेल लाउड नहीं है, फ्रीक्वेंसी बहुत हाई है, बहुत दूर से आपको सुनाई देगा वो, the gongs.
Frequency, they have a symbol which is like V.
हाँ, new. That is called new. Nu. वो था mu, ये है new. I didn't use it because you are not familiar. But when you go to grade 11, they'll write C equal to lambda nu. ऐसे लिखेगा. C means
V equals wavelength.
Yeah.
C means C is a typical speed which is speed of light. बाकी सब स्पीडों को हम V से डिनोट करते हैं. C मतलब speed of light. C is speed of light. So when you are dealing with the sun's radiation like gamma rays and all, at that time we will use C, because all these are coming at the speed of light. Light की speed, radio wave की speed, Tata Sky की speed, Airtel की speed, Jio की speed, all are same. 3 into 10 to the power 8. Everyone differs in their wavelength, and I had posted you once,
Yes,
like BBC का post किया था. You multiply anything, you will always get 2.99 आएगा into 10 to the power 8 आएगा. Into 10 to the power 8. So always go to a radio station, listen to the call sign. This is the BBC on 29 meters and so much frequency. They'll always announce that. That's the protocol. So once you give your meters and just multiply both those, you have to get 2.99. Approximately 3 into 10 to the power 8. Anything else on sound? You should do, agar numerical आया, one numerical may come on speed, frequency, time period. Don't be an idiot, not see the units. Units पे नजर रखिए. They will not give you in meters and second, or they may not tell you the time period directly. We don't need time period for speed. We need frequency. For frequency, we need time period. Time period कहानी में रहेगा. A so and so speaker beats so many cycles in so many seconds. That gives me time period. From there, I get frequency. From frequency, I will multiply it with the waves. That's how we get it. बोलिए सर, कैसी रही कहानी? मजा आया? हाँ. Loudness and
intensity of
loudness is how you perceive. See, loudness, I'll tell you. Okay, now see what happens when you. So रोकते हैं. Okay. कौन सा था? ये वाला. Yes.